to ship source. Sometimes it's contract requirements where they've sub-licensed technology and they're not allowed to open source. There's interesting things like if you're doing a cell phone and you're doing a driver that controls the radio, the FCC restricts power levels and frequencies and so forth. And if you open source your driver and your device was out of compliance, are you liable for that? So there's some interesting intricacies in being able to open source stuff. So I personally, I give companies a little bit of latitude when they don't open source stuff. But when they do, there's certainly a lot of advantages to that and folks fixing stuff. Now, the gentleman back here said something that I wanted to kind of mention too, that there's kind of a saying in the open source world that nobody has to reinvent the wheel, that everybody benefits when someone solves the problem. And the GPL doesn't require that. In fact, it's fairly common practice that folks do not release stuff back. The GPL doesn't require giving back, technically. It requires what I call giving forward. So original authors of code oftentimes don't get fixes for their code, even though fixes exist. And in fact, multiple fixes. And at any given time, there may well be lots of versions of drivers that independent companies have fixed, and they don't feel motivated for whatever reason to contribute that back. So it is a bit of a problem, but in practice, in kind of reality, things do work pretty well. There's tangible benefits in contributing back, and you don't have to continue to support it yourself and whatnot. So for non-altruistic reasons, but for real business, practical reasons, folks do find value in giving back, and that continues. And more and more folks are convinced of that. So I think that's proven to be pretty effective.
I think for us, we're mainly on the server side. There's slightly less mayhem on the server side. You don't have laptops are murder to support because and I think that it is even with Linux. You look at its ubiquity, and it still struggles on the laptop because of Wi-Fi, because of all the devices and so on. And I think it's hard to do it to not do it the way either Windows or Apple have done it. That is to say, you run on everything, or you run on only your thing. On the server side, things are a little better, or maybe even a lot better. It kind of depends on the particular component you're looking at. NICs, for example, are pretty straightforward, and in part because NIC vendors, Intel doesn't actually want to have a from-scratch driver rewrite with every new NIC. It's not in their interest either. So the NICs are straightforward. HPAs less so, because you've got vendors that actually want to put a bunch of proprietary glop into their RAID controllers, what have you. I think that historically the challenge has been not being able to get the source code. This is where I think we, in all these open source systems, really need to work together, and I think that we have and do. And we are able to, when a vendor, thanks to the position that Linux has, a vendor has released a driver that's open source, even though our driver models are completely different, we in other OS communities can take a look at that driver, and even if we can get ported across, great. If we can't get it ported, we can at least understand what the device interface is. So I think that open source has been tremendous here, and has been tremendously valuable. I think we still need to put pressure on vendors. I think that we've got a very peculiar problem in Illumos that we're going to get over this hump, but we're dealing with. We're unprecedented in that we are a source base that leapt the chasm from proprietary to open. Unlike BSD, unlike Linux, our heritage is actually proprietary. We leapt that chasm, really being the first OS the really mainstream OS to do that. And then in just a crazy leap, a crazy twist of fate, Solaris became anyway, the first operating system, then leaped back. The Solaris went from being open to now being proprietary again. So I guess two firsts there. We've got a very, very strange phenomenon that you have when they open source the operating system, a bunch of device vendors were very excited about that development and contributed their drivers into the operating system that has now been made proprietary again. So we do have this kind of strange problem that we've got particular vendors like Broadcom, LSI, others, that we're having to go back and kind of reestablish covenants with. You know, it's a challenge, it's an organizational challenge. I think that the way to do it is that we work together. We work together as a community across our technologies, and we go make the vendor, or help the vendor do what we need the vendor to do. One other thing I would say about that peculiar bit that we have, at least in ZFS, ZFS was really designed around, instead of having incredibly intelligent hardware that you were relying upon to always get it right, ZFS made the realization that actually, no matter how much you pay for your hardware, it's not going to get it right. You actually want to have cheap, stupid hardware, and you want to have smart software. ZFS built the smart software. We're actually having a hard time getting the stupid hardware. It is actually hard to find HBAs that pass through. Every HBA insists on having their own little proprietary co-op in there. No, I want to be a RAID controller. It's like, no, I really don't want you to be a RAID controller. Just give me all the spindles, please. So that's a challenge that we have as well. I think it's a challenge that we are surmounting. So I think the progress is being made, and I think that there's a myth out there that you know, for all of these operating systems, that, oh, well, you can't possibly, you know, you're different from these other systems, you can't possibly survive because of the devices. Well, the fact that we're all open source is what allows us to survive. The fact that we can all actually borrow from one another is what allows us to survive. So that really is kind of the key difference now from a decade and a half ago.
I know that since early days there have been certain of the common drivers like the Adaptec AIC7XXX that had always been permissively licensed, so that there was not this nonsense of having to have separate trees for different OSs. It was always maintained as a common project.
So, I mean, everything everyone has said is probably true. It would be nice if hardware manufacturers produced the sort of books that they used to produce. Even for processors these days, especially in the embedded space, with ARM and so on, there often are lots of bits that you have to work at to get information about. I think Rob Pike said once that, you know, there isn't a principles of operation for a lot of this stuff, referring to the System 360 370 series documentation, which was very detailed. And actually, that's true of quite a bit of the documentation of mainframes and computers in the past, because they expected people to have to write software for it at a low level. And it's true that there often are Linux drivers that you can use to get some information about how to drive a device. And we do that. I would say though that having worked on a driver where I've had the Linux driver to hand and also some what I call proper documentation for the hardware, it's much, much easier to, and the driver is much better working from the hardware documentation, because the model that you have, how you want to drive the device, is often quite different. Or else the driver just does things and you can't work out whether this is absolutely essential or whether they've misunderstood something or whether they had a buggy version of it, which is not unusual, and therefore had to do something you don't seem to have to do. It would be much, much better if people just document the hardware.
Your comments, and then we'll have to wrap up pretty quickly after that.
So we had a group of Intel engineers at the shop a couple months ago, and they were watching us assemble servers. And we showed them we're mostly an Intel shop at this point in the game, and we walked them down the lines where the guys were putting processors into servers, and they said, well, you know, that doesn't look like an Intel motherboard. We went, well, it's not. This particular system is getting a super micro motherboard, and the engineer goes, you can do that? And we were like, what do you mean? He's like, you could put an Intel processor in a super micro motherboard? I thought they only worked in Intel motherboards. And very brilliant person. Very, very brilliant person.
So you're saying it's just as well they don't document the hardware?
When you talk to this guy, he could make your brain explode about some little part of a subsystem of a modern processor that he worked on, and knew far more about it than anybody at our shop, for certain. And I think what that reflects is that modern hardware is getting really, really complicated. And the ability, if Intel says, hey, we're going to give you a preview of what we're working on, here's our next generation hardware platform, and you get to see it first. This will be out in about 6 months. Here you go. The reality is to get an operating system in the shape to use that takes longer than 6 months at this point. You know, it's not a basement project for Jim and Steve to go home at work every night and, you know, after work and go make this hardware go. And without specs at a certain level, you know, the latest Westmere processor has hundreds of millions of transistors in it, and the spec book is, you know, thousands of pages long, and great, you have the specs, good luck, have fun, you know. You really need a driver team at Intel helping you with your operating system. We were working on a RAID controller driver for the new LSI Thunderbolt RAID controllers that are new as of a year ago. And you know, we started, hey, let's get some hardware specifications, let's get some hardware docs and stuff like that. And talking to LSI, they go, actually, those docs don't exist. We haven't had time to update it, right? You know, we have our engineering team that's worked on it, and they know a lot about it, but the documentation you're looking for, we simply don't have. You need to talk to these 6 guys if you have questions.
I sent LSI an email asking for the documentation for that part this afternoon.
Yeah.
So
Good
thank you.
luck.
Actually, you just saved me an enormous amount of time.
Yeah.
And actually, it's not that they won't give it to us; it's that they actually don't.
They don't have it.
That's quite
SVLUG Part2 service.
That's quite
It's clarifying.
Yeah. So in reality, you know, open source projects need teams working inside these hardware vendors to provide drivers. And so you'll find that Intel drivers, for NICs, for instance, they have a FreeBSD team that works on the driver. They have a Linux team that works on the driver. NVIDIA has an entire room full of people that work on the Linux driver for the NVIDIA cards. You know, Chelsea has a room full of Linux guys, a room full of FreeBSD guys, you know, a room full of Solaris guys, you know, working on these drivers. You need that sort of commercial support because at the end of the day, you get, you know, 16 pieces of technology from 8 different people that are all going to be released new, and you're behind the 8 ball, and then it comes out. 3 months later, you support it, and 3 months after that is end of life.
Yep.
And they're on to the next one, you know? And you're going, but I haven't even qualified my new product on it, and you guys aren't even making it anymore, you know? And now I'm paying more for the old stuff because it's EOL, you know?
Oh, yeah.
And so without commercial support, open source is really in a tough place. You know, the IBM PC, the XT, you could read the hardware manual for it in a couple of days. You know, these days you could take 2 years and you couldn't read the hardware manual on a Westmere processor. You just couldn't do it. So you need commercial support. And I think that hardware companies are starting to realize that, you know, open source isn't a niche anymore. It used to be if it wasn't a Windows box, it was by definition niche hardware. And I think you're starting to find now that that niche is a significant percentage of the market.
We're now pretty much up against our time limit. Time has passed quickly and wonderfully. Thank you all. We have, perhaps, we can steal a few minutes for some concluding remarks. I had in mind previously to ask you folks where you thought your systems are likely to be in 5 years and where you'd like them to be in 5 years. It's not necessarily the same thing. But any other concluding remarks you folks feel like maybe would be most welcome?
I'll say something quick. Linux's pace of development has accelerated over its whole lifetime, I think, and I think that will probably continue. I don't have a vision for where it's going to be in 5 years, but I feel pretty confident that it will continue to be successful.
Yeah, so I think that that for us, I mean, you'd have to talk about particular technologies, about where we're taking dtrace, where we're taking zones, where we're taking CFS, where we're taking all of these technologies. And I think we've got you know, ideas for all those technologies. None of those technologies is done, and we are, in particular, you know, cloud computing changes everything. It changes everything in a very exciting way. One thing we didn't talk about at all tonight that I just want to touch on very quickly is virtualization. And you know, we've had this this tremendous revolution in the last couple of years with virtualization. And in particular, VMware showed Intel and AMD that a market existed that they did not know existed, which is for virtual x86s. It's hard to remember, but when VMware started, it was reasonable people thought you could not virtualize the x86 architecture. In what is almost a tragedy, they invented the space, and then of course Intel and AMD put in the microprocessor support that obviates all the technology that VMware had built. So VMware's in a bit of a bind. That is very kind of unfortunate. But for the rest of us, and for KVM in particular, this is terrific. So we've got now in the microprocessor unbelievable support from Nehalem and later CPUs, and Sandy Bridge, West Mirror Bridge, so on. Unbelievable support for virtualization. And that's why we ported KVM to Illumos, allowing it so you can really view your OS as an application platform. Your OS in the KVM model, your operating system is really just a process. And it looks and feels and smells like its own hardware, but it's virtual hardware. So and we think that we're already seeing some cloud computing, but certainly we think the virtualization's got a tremendous future to it, and it actually unlocks us, because if your application is bound to a particular operating system, be it Windows, Linux, what have you, you can now run that in a virtualized image and now make a different choice on your hypervisor. So in terms of Illumos, we actually view ourselves as a superior hypervisor. And all the technologies that we're developing are really around being a multi-tenant operating system and a hypervisor.
Yes, so there's several groups that have plans for the future, because as you alluded to cloud computing, there are a number of things that have changed radically since Timeline and Inferno were both first developed, and I think there's several groups that, including me, that are thinking again about how to change things for a rather different future.
I think that I've seen BSD lose its impact in networking and gain impact in storage. And I think that you're going to see, BSD is behind a lot of storage right now. I think you're going to see that to continue to increase, and I think you'll continue to not see it behind the scenes in the embedded field. It's the operating system you've never heard of that you use every day. And that's going to continue to grow. So.
Thank you all, and thank you everyone. We usually have an after-dinner gathering, and it's traditional to not let our guests pay if they want to join us for dinner. That's over at Frankie, John, and Luigi's 2 restaurant, Italian restaurant, on El Camino Real. It's between Castro and Shoreline, on the far side of El Camino Real. So there's typically a set of cars and other vehicles on the way to the restaurant. If people can indicate whether they want to attend, we can let the restaurant know how many we're mobbing them with. Show of hands. Thank you, everyone.
And one more thing, we have a bunch of sandwiches which are still there. So if anybody wants sandwiches, please take them.
Various interesting bits.
FreeBSD probably has the most mature any of the BSD projects out there.
Well, I mean, just use both camera views to generate one sort of all of the screens.
Is that where the slides are?
Yeah, at the end, we'll give it to you right now. That's where the slides are at. So that's the last slide. We'll go back to the beginning. And when John's ready, we'll get started.
You should be able to take a picture of that key code.
Yeah, it should be able to.
All right, I got it.
You got it?
Yeah.
Okay, I'm not gonna use the microphone, because there's only 4 or 5 of us. Tony will be here in a minute, but we'll just get started here. All right, well, thanks everybody for coming, and
You want to go ahead and start early? And if we, and then even if we
Yeah,
do,
excuse
we'll
me.
let Ali talk to this
Ali,
huge
why don't
crowd.
you start up?
Yes. Can you hear me? I just wanted to say, you know the drill. Hi guys, cell phones, please silence your cell phones. Next month we're having Gabriel done, and the talk topic will be processing.